Hello everybody, it is Thursday 9:15 in Integrated 1, and we talked today, if you weren't here, about this f of x. And what the heck is f of x? We talked about the fact that if you don't remember anything, f(x) and y are the same thing for us. Later on we'll talk more specifically, but when you see f of x, just think y. So the example I had was we graphed y equals 1/2 x minus 3. So we start at -3, y-intercept, starting point. We had a slope of up 1 over 2, up 1 over 2, up 1 over 2. We graph this line. Then I asked the kids, okay, is this line a function? And they said, yes, it is a function because, one, it passes the vertical line test. Also, every x value has exactly one y value. So it is a function. It is a function. So because this graph is a function, we're going to call it a function, so we use f of x. So we put f of x, instead of y equals 1/2 x minus 3, we can say f of x because it is a function. Now remember, the y and f of x are kind of the same thing, but it is a function, so we say f of x because it's the function of x. Now, that makes x the independent variable, and f of x or y the dependent variable. So anything that is a function, we can just say f of x. If it is, instead of calling it y, we can use f of x. Okay? Now, we went back to our book then, and in our book, we talked about our graphs. And we remember looking at all these graphs from before, and it looks like if we read the explanation, it looks like Judy, when she did her grouping, Judy grouped D, K, and O all together because D is not a function, fails the vertical line test. K is not a function, fails the vertical line test. And O is not a function, definitely fails the vertical line test. Okay, so that means all the others, A, B, C, not D, E, F, G, H, I, J, but not K, L, M, N, but not O, and then P, Q, and R. All of those graphs, those other graphs, these graphs are all going to be functions. So functions and not functions. So then we had an example in class. Well, let's look at a real world example. So here's our example. U.S. Shirts charges $8 per shirt plus a one-time charge. Okay, so we're going to charge $8 per shirt, 8T, plus the $15. So we got this cost, $8 per shirt plus 15. I said, well, wait a minute. That is a function. We know it's a function. We could graph it. So since it's a function, instead of writing y, we can write f of x. So y and f, because this is definitely a function. If you were to graph it, I mean, really, it looks something like this, right? It is a function, okay? So then we said, okay, well, if it is a function, instead of writing y, we can write f of x. Well, I wanted to go a little bit further than this. Instead of f of x equals 8x plus 15, I said, well, let's make it instead into something instead of f of x. How about c of t? F of x, c of t, because it's the cost per t-shirt. So it gives us more information. The cost per t-shirt is equal to 8t plus 15. Now, again, y is the dependent variable, or c of t is the dependent variable, and x is the independent variable, or t is the independent variable, okay? So we just changed it. Instead of writing y, we wrote it to f of x, and for me, instead of f of x, let's make it, instead of f of x, let's make it cost, or c of t. Okay, then we turn the page, and we talked about domain and range. Now, we talked about the fact that, in this shirt, we said, let's try and make this practical. So I asked the kids, well, how many shirts are we going to make? They said, we could make up to 1,000. They made that up. They said, okay, 1,000 t-shirts. They said, okay, we can make 1,000 t-shirts on our best day. So they said, what about our worst day? Well, on our worst day, we can make 0 t-shirts. On a good day, maybe 500. Some days, maybe 20. But the days that we have days off, that we take off, we make 0. So we can make 0 t-shirts. We can make 10. We can make 15. We can make 500 t-shirts. We could make 850. All of these, whether we make 0 t-shirts, we make 50, maybe we make 850, but our best is 1,000, is all of those. On any given day, we can make anywhere from 0 to 1,000 t-shirts. So that is our domain, is how many t-shirts. Anywhere from 0 to 1,000 t-shirts. And of course, we can write it like this. 0 is less than or equal to t, which is less than or equal to 1,000. Okay? So if that's the domain, then we talked about, okay, what about the range? Well, range is the cost. So the lowest cost is $15. Let's see, we don't make any t-shirts. Take the day off, we go home, so our cost would be $15. But if we make t-shirts, it's going to cost us. It might cost us $100. It might cost us $300. It might cost us maybe up to, all the way up to $8,015, because the most t-shirts we're going to make is 1,000. So our cost is anywhere from $15 to $8,015. So that's a verbal, or if you want to write it in set notion, our cost is greater than or equal to 15, but less than or equal to 8,015. Okay, then we kept going. We looked a little bit further in the book. We looked at these graphs. So domain is all x values. Domain is all x values, or another way to look at it, a domain is how wide. So this graph has x values from -7 to 6. That's how wide. And all of these x values are included. So the book says from -7 to 6. Now I circled this 6 because if I look at this graph here, right here at 6, I have an open circle. So there's no dot. There's no dot here at 6, so it does not include 6. So we say it's from -7 to 6, but not equal to 6, okay? We looked at the range. How tall is it? The range, how tall? We said the height of this graph goes from -4 up to 8. -4 to 8, so how tall is this graph? Goes from -4 to 8, so that's what this says. On g of x, it goes from -4 to 8, okay? Now the other graph is different. These arrows tell me it keeps going and going and going. These arrows tell me it keeps going and going and going. So how wide is this graph? Well, really, it goes forever. It goes forever. So we could say from -infinity all the way up to infinity, but I like this better. It's easier to say all real numbers. And the symbol for that is the cursive R. So how wide is this? Forever wide, infinity to infinity, or I like to say all real numbers. What's the range of this one? Well, reach for your range, or how tall is it? Well, it starts at 8 and goes down. Nothing up here. It starts at 8 and how tall? It starts at 8 and goes down. So we could say y is less than or equal to 8. Okay? Now, it says consider the graph cards from the previous lesson. Okay? Now, we want appropriate range and domain, or domain and range. And that is our homework today. So our assignment or our homework is to do the cards. So we're going to do the cards and talk about domain and range on the cards. I did a couple of them, and then we need to do all of these for our homework. So that's it. If you have any questions, come see me. I'm happy to help you. Quiz tomorrow on all of this.